Why visualize data? Today, I'm going to go over some of the basic reasons why we choose to visualize data and how it helps us to represent information so that we can keep track of it, uh, uh, communicate about it, and gather insights. So one example for how we visualize data is by thinking about it as a representation. Representations can help us with tasks. Now, imagine that you are taking several different medications that your doctor has prescribed to you, and you realize as you look at the bottle that it can be quite confusing how all of this information that makes sense in written form and in one particular instance can become quickly overwhelming for keeping track of what to take when you start to add up too much information. So the first drug, you're supposed to take one tablet 3 times a day. Second one, you take one tablet every AM. The next, you take one tablet before meals and at bedtime, one tablet every 12 hours, one tablet every 12 hours as well. And then the last one you take once a day. So how would you keep track of this information? Well, one way to take this information, the data given to you, is to represent it in something like a table. And by reorganizing this information into something where, let's say, instead of by hours, we focus on 4 particular time points: breakfast, lunch, dinner, and bedtime. Now what we can do is reorganize this information so that we can understand when we're supposed to take particular drugs. So for instance, for breakfast, I have 4 pills, lunch, 4 pills, dinner, 3 pills, and bedtime, 4 pills. And so by transforming information into format that helps us um, gather knowledge and information, we can better do the tasks that we're interested in. And by thinking about data visualization, it's oftentimes better to think about this as spatializing the data, moving information into a spatial format. And one example of that is by thinking about which number is larger. So imagine I have 284 versus 912. It's pretty easy to tell that those numbers are different. And same with 284 and 312. Both of them, I can tell that the number on the right is larger, but this becomes a lot more pronounced when I try to spatialize the data. Now I can see just how big of a magnitude the changes are between the first and second number for scenarios A and B. And so by spatializing it, by giving it properties that allow us to interpret how large it is, we're able to use our visual systems to now interpret the information. And this is really at the heart of data visualization. It's how can we take a bunch of information, turn it into a perception, into some kind of visual that people can easily interpret what was being shown. I'd like to argue that data visualizations are models. Now, I'm not talking about the kind of models that go down a runway and display clothes, or the kind of models that you might see at a car show, which are physical models. These are more abstract models. And we're going to define these as simplified, purposeful representations. And we do this because it's really going to help us think about how we design data visuals as a model of information. And by doing so, we hope to visualize information that users can find useful and easy to use. And some of the best data visuals are those that are going to use our visual systems in order to process information and reduce the cognitive load it would take for us to look at the data in its raw format. So an example of this is something you might have seen in the news over the last time period. So here is some reporting from the New York Times about the tracking of coronavirus in Washington and the latest case counts, as well as vaccination rates. And as you can see, there's a lot of information here. Um, but at a glance, you can kind of see where we're at in the state of recovering from the coronavirus and the tests and all of that. Now, why do I bother showing you this? I show you this because it helps us to understand data visualization as models. So for instance, these are simplified representations. They're simplified because they help us remove the complexity to show a particular aspect that we want to focus on. It intentionally does not show all the details. Even here, you can see there's these extra little lines that pop up because of kind of anomalies that happen with reporting on the weekends and then those data getting aggregated. But we don't see all the places where the cases were recorded. We don't know how that fits with the positivity rate or how much error is in this. But it does show us at a glance what the state of the positive case counts was at different stages of the pandemic. So it's simplified because it removes a lot of extra details that could distract us from the point. Data visuals are also purposeful. So this is an image of a periodic table of elements, which chemists use to help fill in what were the missing elements. And most tables also contain information that help chemists understand things like the atomic mass, the atomic number, and be able to understand the properties of the different elements. Now, this is a purposeful representation because it was really designed around a particular focus. It was meant to show the order and groupings of the elements in a way that could help people make sense of the patterns among these different atoms. So when you are designing, you should always focus on a particular purpose or function that you want your visual to provide. And that will help streamline the design process, but also make it easy to evaluate what the purpose of your visual is. An image without a purpose is really difficult to evaluate if there's no way of knowing what it was supposed to do in the first place. And data visualizations can be thought of as models also because they're representations. So this is a famous painting, and it says "Ce n'est pas un pipe," which is French for "this is not a pipe." Now, the reason why this is not a pipe is because you can't smoke it. It is an image of a pipe. And we all know that images aren't things you can smoke out of. So this is really important to understand though, because it helps us see that in this case on your screen, this is actually just a representation of a painting that was made of a pipe. And so you're seeing pixels. You're seeing little lights light up on your computer or tablet or phone, and that is helping your brain interpret an image of a pipe. So it's important to recognize that data visuals are representations because they are symbolic substitutes for the real objects, right? With the case numbers in the previous visual, each of those represent a positive test that appeared. And additionally, we see that there are features that correspond to the represented object. So most representations don't just float abstractly, they have something that you can tie back to the original object, whether it be a dot on the screen, like in a scatter plot, or the size of the bar representing the frequency or count. So oftentimes there's some aspect that you want to connect back to the object. And really what we're looking at is things that are abstracted or transformed for the purpose of perception, in order for you to provide information to your audience in a way that they can perceive it and make sense of it. We'll talk more about some ways that designers can use these elements for perception later. So hopefully I've convinced you now that it's useful to think about data visuals as models because they're simplified, purposeful representations. And it's really meant to show data in this context. So at their best, they help tell a story and give meaning to the situation you're trying to visualize. They help engage the audience and encourage them to explore and question the data. And they also can reveal degrees of uncertainty, which can help make informed decisions when there's a lack of clarity around information. At their worst, however, they can be used to misinform people, either intentionally or unintentionally through bias. They can also have burdensome distractions that can confuse the audience or create too much effort to prevent engaging. And oftentimes they leave at the worst, they leave viewers asking, so what? What's the meaning of this data? So think about these things as you're designing your visuals because they'll oftentimes come up in really unexpected ways, but a trained eye can help you clarify the meaning that you intended. And finally, I want to talk about data visualizations as a response to statistics. Now, both statistics and data visuals are meant to help draw inferences from data, look for patterns in the information. But when you display data, oftentimes it can show you things that are lost when you do calculations through statistical formulas. So this is called Anscombe's quartet, and you'll notice on the right here we have 4 scatter plots, and they all plot the x-coordinates against the y-coordinates to show trends as indicated by the blue line. That's a line of best fit. It helps to show what the general movement of the data is in relation to between the x and y coordinates. Now you'll see that each of these have different patterns, but if I were to use statistics to summarize each of these data sets used to make each of the 4 images, they would all have the same mean of the x. They would all have the same mean of the y across this way. So they would average out to be the same. They would also have the r squared value, which helps to see how correlated these are by reducing the amount of error. They also would have the same standard deviation for x and the same standard deviation for y. But as you can see, they are not the same data. They are, in fact, very different sets of data. And because of that, we need data visualization to help uncover the patterns that we see. And to take this to another extreme, Alberto Cairo created the Datasaurus, which repeats the same trend, but shows it in many creative ways, all of which have the same x average, the y average, and standard deviations for both across each of the images. So pretty creative, but as you can see, the statistics really oversimplified what's going on in each of these patterns.